everyone, we are Group 41 and today we will be presenting our project titled Proposal of ICT Infrastructure Development for BITC 5 Sdn Bhd. Before we begin, let me introduce our team members. First, we have Aida Rahia. Second, we have Aida Davita. Third, we have Nur Adeline Natasha. Next, we also have Nur Safia Shazwani. And finally, me, Nur Shifa Shamini. This project aims to develop a comprehensive network infrastructure for BITC 5 Sdn Bhd. The company operates across 3 main locations. First, the HQ in Shah Alam and 2 branch operations in Kulim and Skudai. Our primary objective is to design a functional network environment that fulfills hardware provisioning and efficient IP addressing using the VLSM technique. The ICT requirement we focus on are designed to support 3 core departments: technical, management, and sales. This ensures seamless connectivity and verified access to the corporate web server at www.bonus.com. Okay, now let's look at the logistic detail through our physical diagram. We have segmented the infrastructure according to the building structures. 1. HQ cross-section in Shah Alam. This server as the network hub where the server room is located, housing the web and DNS server. We have partitioned the office by department, technical, management, and sales using wired connection to ensure high stability. Next, branches, which is Kulim and Skudai. For the branches, we implemented wireless access point and switches to facilitate staff mobility and flexibility. Next, department partitioning. Each department has its own physical segment. For instance, devices such as PCs, laptops, and printers are allocated based on the capacity requirements for each department to ensure a systematic workflow. Next, interconnectivity. All 3 buildings are logically interconnected via routers to ensure smooth cross-location communication.
Assalamualaikum, my name is Nur Adeline Natasha and I'll be explaining the brand of our network, the topology, and the addressing scheme. As you can see on the screen, we have designed a star topology. Our Shah Alam HQ serves as central hub, linking directly to the Kulim and Skudai branches via ISP managed one link. Look closely at the HQ router. It is the heart of our operation. We have labeled every device with a clear convention like PC1 or access point, so we can identify every node instantly. The HQ router connects to the internal network via interface Gigabyte Internet 0/0 with the gateway 172.168.5.65. Now, how do we get these addresses? For HQ, we will assign the base network 172.168.x.64/26. As Group 41, we have 5 members, so the variable x becomes 5, giving us the static network of our operation. Using a 26 as subnet mask, we created a single broadcast domain with 62 usable IPs. We allocate them systematically. Technical flow starts at 66. Server form occupies the middle range 82 to 85, and the sales and marketing flow use the wireless range up to the 95. Now, let's look how we handle our branches. We were given a single large block. While this could hold over 500 devices, we need to divide it fairly and efficiently between Kulim and Skudai. We use VLSM to perform a surgical split. By increasing the subnet mask from 23 to 24, we essentially create 2 equal containers. Kulim received the first half starting at 10.0.0.0 and Skudai received the second half starting at 10.0.1.0.
Hi, my name is Aida Davita. In this slide, I will explain about HQ device configuration. I will show IP configuration for both wired and wireless using ipconfig command. First, on PC1, I open the command prompt and type ipconfig. From the output, we can see IPv4 address, subnet mask, and default gateway. This confirms that the wired host has successfully obtained Next, on the wireless host, I run the ipconfig command to output shows. This indicates that the wireless host is properly configured and connected within the same network. To support our hard data separation, we have configured two separate wireless access points, one for sale and one for management. Both networks are built for security and reliability. They use WPA2 escape with AES encryption, which is the core standard for keeping our data private. HQ cell runs on channel with password FTMT 061215. HQ management also runs on channel 6 with the password IDA1234. We have set a 140 meter range for both, ensuring that every corner of the office has a stable connection. We set up and give each department its own dedicated link while keeping the network protected from outside access. This video demonstrates the initial status check of the HQ router in our network. First, I go to type as you can see, Gigabyte Internet 00 is currently configured with the IP address 1 and its status is up, meaning it's active and transmitting data. This slide shows the DNS configuration on the server. First, the DNS service is enabled to allow the server to resolve domain names. Next, and a record is created. The domain name www.bonus.com is mapped to the IP address. This allows client device to access the server using a domain name instead of an IP address. As a result, network access becomes easier, more user-friendly and efficient.
Now, I will demonstrate the configuration for our two branch locations, which is Kulim and Skudai. For branch 1 in Kulim, we have configured house A for the service department with 4 wired PCs and house B as the staff hostel for wireless notebooks. Next, for branch 2, which is in Skudai, we implemented a 2-story building setup. The ground floor hosts the service department's wired PCs, while the first floor provides wireless connectivity for 10 notebooks in the As required, we assign the first IP address of each subnet as the default gateway. Here, you can see the configuration for our wireless access points and the IP addressing for our host. We ensured that the DNS server for all devices is set to 111.11.33.2 to allow for proper domain name resolution. Finally, to verify our application layer connectivity, I will access the external web hosting server by opening the web browser on one of our branch PCs and typing the URL www.bonus.com. We can see the page load successfully. This confirms that our routing and DNS settings are working perfectly across the entire infrastructure. Finally, to verify our application,
first, I am pinging from PC2 in HQ Technical Department to a wireless notebook in Skudai Staff Hostel. As you can see, the reply is successful, proving that our routing between Shah Alam and Skudai is operational. Next, I'll test the connection from branch 1 in Kulim using PC23 to the server farm in HQ. Again, the ping are successful. This confirms that all hosts, whether wired or wireless, can communicate across the entire infrastructure. Next, I'll test the connection from branch 1 in Kulim using PC23 to the server farm. For ISP or WAN boundary, note that we did not modify the WAN environment, as it is the ISP responsibility to manage the cloud connection between our sites. In conclusion, Our team has successfully designed a network that meets all BITC 5 Sidang Berhad requirement. We have implemented a functional 4-story HQ and 2 remote branches using an efficient VLSM addressing scheme. Our findings show that the network is stable and provides full access to essential services like the web hosting server. For future works, we suggest adding redundancy links between the branches and implementing advanced security protocol such as firewalls to further protect the company's data. Thank you.